Hello, everybody. It's Mrs. Pound, and we're continuing on with our study of Chapter 4.3 on types of machines. So, we're taking a look at three types of simple machines today in Section 4.3.4. They are screws, wedges, and wheels and axles. And part of the reason is because, as you will see, these are really kinds of variations on the other simple machines that we have talked about, namely our inclined planes, our levers, and our pulleys. So our objectives today are to describe the advantages of using different simple machines and to calculate the mechanical advantage of screws, wedges, and wheels and axles. So a screw is a simple machine that consists of an inclined plane wrapped around a cylinder, and an example is jar lids. So this is a variation on an inclined plane. So the formula, though, for a screw is different than for an inclined plane. The mechanical advantage is equal to the circumference divided by the pitch. And the pitch is the distance between each of the threads on the screw. And we can find the circumference if we know the diameter of the screw. Remember, circumference is the diameter times pi. Now, one note, when using a screwdriver with a screw, use the diameter of the screwdriver handle in the formula. And we always use a screwdriver with a screw because it's actually really hard. We need to get a little bit more mechanical advantage because just sticking our fingernail or something in the top of a screw, we just cannot do that. So an example of a problem might be, calculate the mechanical advantage of using a screw with a pitch of 0.1 centimeters and a head diameter of 0.4 centimeters, and a screwdriver with a handle diameter of 3 centimeters and a shaft length of 10 centimeters. So the first thing we have to do is write down our formula. Mechanical advantage equals the circumference divided by the pitch. Now, if we look at the problem again, we find the numbers that we need. For the circumference, remember, we're going to go with the screwdriver, so we need the diameter of 3 centimeters and the pitch of 0.1 centimeters. So we plug those into our equation. Remember, I said that we find the circumference by multiplying the diameter times pi, which is rounded off to 3.14, and then we divide by the pitch. When we do that, we have 9.4 centimeters divided by 0.1 centimeters, which is a mechanical advantage of 94. That is huge, isn't it? So by using a screwdriver, we really multiply that mechanical advantage. Now, a wedge is a simple machine that consists of two back-to-back inclined planes. So we kind of have a theme going on here with inclined planes. And some examples of wedges are knives, chisels, plows, and axe heads. Its advantage is that it changes the direction of the force. So we're taking a force that's going down and the wood is split apart this way. So the force ends up being perpendicular to the way you are hitting the wedge. So compared to an inclined plane, it is two inclined planes back to back. It has the same formula for mechanical advantage. And when using a wedge, the impact force is applied to the height. The output force is perpendicular to that force. So we're applying it to this height area, and it's perpendicular. The input force on an inclined plane, on the other hand, starts at the bottom of the slope, and the output force moves the object up the slope. So our formula is the same as for an inclined plane. Mechanical advantage equals the length of the slope divided by the height. And finally, our wheel and axle. This is a simple machine that consists of a wheel attached to an axle that has a smaller diameter. So this is the wheel. The axle is right here. Examples are screwdrivers, wrenches, steering wheels, doorknobs, and a fan. Our formula for this for mechanical advantage is the wheel's diameter divided by the axle's diameter. And so an example of a problem is if a wheel's diameter is 25 centimeters and the axle's diameter is 5 centimeters, what is the mechanical advantage? Well, remember, we start with our equation. Mechanical advantage equals the wheel's diameter divided by the axle's diameter. We plug in our numbers, 25 centimeters for the wheel, 5 centimeters for the axle, and 25 divided by 5 is 5. Remember, for mechanical advantage, I haven't mentioned this in this video yet, but the units cancel out, so we never have a label for mechanical advantage. Now, a wheel and an axle is like a lever because the advantage depends on where the effort force is applied. When the force is applied to the wheel, it is like a first or second class lever magnifying force. That's why on a boat lift like this, see that huge wheel there? That huge wheel is there because it multiplies our force. If that wheel was smaller, it wouldn't multiply our force as much. Now, this lift also uses pulleys to further magnify that force, but that is why the wheel is so big as well. When the force is applied to the axle, it is like a third class lever magnifying speed. So here, the axle is in the center, and these fan blades go faster than the axle is moving around. So it magnifies speed, and that's why you get a breeze from a fan. So our objectives were to describe the advantages of using different simple machines and to calculate the mechanical advantages of screws, wedges, and wheels and axles. And we're going to be getting more practice on calculating those mechanical advantages in class. Now, don't forget your 5 questions. And what I want you to do is, by your name, I want you to write or draw a picture of what your favorite simple machine is. Which one do you find maybe the most interesting or the most useful? So 5 questions and a picture or writing what your favorite simple machine is.